Hello everyone and welcome to today's webcast on PedRamp design with CTC AutoGrader and Corridor Mapper. My name is Brian Lewandowski. I'll be doing the presentation today. I'm the product manager at CTC Software for all of our civil products. So thanks for joining us. One note to mention, this webcast, PedRamp grading, is kind of building on a previous webcast using Corridor Mapper, one of our primary tools. That previous webcast is called Dynamic Intersection Design with Corridor Mapper. So be sure to check that out on our YouTube page as a precursor to this webcast. So we're going to be using some of the CTC tools, which are plugins to Civil 3D, to speed up some of this process. One tool we're going to use is called Corridor Mapper. What this does is it allows us to link layers, styles, or object names to subassemblies. In an interface like this, I can choose many different subassemblies at once, link them to a particular layer or style or object name or description. As things are drawn on those layers or styles or given those object names and descriptions, the targets automatically pull into the corridor. We can assign multiple target sets to subassemblies at once. In this way down here, I can control or shift select multiple subassemblies. I can be filtering by type or layer over on this side here to trim down my list. And then there's even manual assignment when linking to a layer, style, or object properties doesn't work. We can just pick in the drawing. We can include XREFs objects or not. And there's even default settings for new subassemblies right up here. As you add new subassemblies to your corridor, they will have default behavior. It even allows mirroring of one subassembly to another. So there's a column called method that is unique to this application, where the standard method is reference, and that would be to reference a layer or a style or an object property. What we can also do is set a subassembly to mirror, and in that case it can mirror a different subassembly. In this scenario, I've got a single boulevard subassembly as the parent subassembly, if you will, and then a set of other ones that are dependent or child subassemblies. So any targets that are assigned to the parent one automatically get assigned to all of the other ones. As that source changes, its targets change, and so do the mirrored subassemblies. So many different applications with Corridor Mapper. We're just going to leverage it for a couple of its features today. The other tool we're going to use is called AutoGrader. This is dynamic grading through linked feature line sets. Uses standard feature lines, but automates the grading of them. You can define parameters in what we call grading families. A simple curb and gutter example. I could draw my gutter lines and then have the tool automatically generate a top of curb, back of curb, and lip of curb for every one of my gutter feature lines. As those gutter feature lines change, so do my 3D offsets from those. You can refresh those families anytime there are those changes, and that's how it redraws or updates the child feature lines. It automatically adds all your break lines to your chosen surface. It'll manage all your feature lines and layers and sites. And you can even save out templates, standard parameters like this, slopes and offsets, to templates for later use on other projects or by other coworkers. So we're talking PedRamp design today. There's a lot of different PedRamps. I'm going to take a common example, but the approach to it would be similar to what I'm going to do today if it's a different design. So I'm going to give you some general approaches. The example will be like we see over here. So a few things to note. These are difficult to grade with corridors alone. There's strict requirements that require detailed grading. That's part of why it's difficult with corridors. The other piece is because the PedRamps become non-parallel or non-perpendicular to the corridor itself, right? For my curb line, I would typically run a baseline in my corridor to have it model out that curb. Well, the sidewalks in this area are not perpendicular or parallel to that baseline. That's where corridors kind of start to fall apart. So feature lines are a good option. However, how we piece those together and then the updating and grading of those individual feature lines can be quite tedious, and that's what I want to show you today using these two tools. We need to be able to generate a quick setup and have easy replication, and we need to be able to update this stuff easily as well. So a couple specs on here. This ped ramp, I've got some minimum and maximum slopes, 5 to 8.3% in the front wings here, and then 2 to 5% in the back. So we're going to follow those as guidelines for our grading. So let's go ahead and jump into Civil 3D. Now again, I'm picking up on that previous webcast, so the state of this corridor is quite similar to what you'll see at the end of that other webcast, the dynamic intersection design with corridor mapper. And what I've got are curb baselines modeled in this area. Okay, it's modeling out this quadrant of the intersection. And I've got full sections modeling right up to where that curb return starts. But then there's been nothing done in the ped ramp area, including any of the curb dropped for where those ped ramps are. So what we're first going to do is generate some of our geometry with just polylines, and then we're going to start turning things into feature lines, and we're going to leverage different pieces of that geometry to quickly grade out our ped ramp. I'm going to do this one right here. We're going to walk through it in slow detail. I'm going to show you how easily we can replicate it over here, because what we're after is not obviously just one ped ramp. We often have many different ped ramps to design and grade out, and each one of them are kind of a unique animal in that the grades and slopes tend to vary from one ped ramp to the next. So we're going to start by extracting polylines from our corridors. I like to start with polylines because it's easy geometry to extend and trim. So we're going to go like this. Okay. Now what we're going to do is we're going to basically box in this area with feature lines. And we're not just going to manually draw them. There's a number of different strategies we'll use here, but to that end, I'm also going to generate a polyline right here, and this will be a feature line. I'm also going to temporarily, I'm going to run a stepped offset of my baseline so that I can offset that polyline right to back a curve. And the only reason I'm doing that is so I can get something to extend these polylines to. So I'm taking the exact geometry from my corridor and using that to draw out my ped ramp. Now we can go ahead and start trimming. I'm going to use this polyline back here as a cutting edge. Okay. I also want to trim in here. And you'll see why in a little bit, but what we're instead going to do for the landing here is have a single closed feature line. I'm going to use a little bit of layer control on this stuff. Ped ramp landing. We're going to call these the ped ramp wings. These ones right in here. Put those on the ped ramp wings layer. And then this one here is the ped ramp sidewalk area, just because it represents the sidewalk. And then this one we're actually going to get rid of. I just created that to be able to extend my sidewalk polylines to. But in a bit, once we start generating feature lines, what I'll do is create a dynamic feature line extracted from the corridor. Okay, so a lot of my strategies, you'll probably have seen some of them here and there. What I'm attempting to do is kind of throw all those tips and tricks perhaps you've seen here and there, put them all together in the best workflow possible, and also leverage the CIM Project Suite, the AutoGrader, and the CIM Manager or Corridor Mapper tool to really automate some of those slow parts of the process. All right, there's our geometry. First thing we need to do is we need to get our curves to be flat curves, ped ramps in those areas. So I'm using this subassembly, or assembly rather, in this area. And what I have is a set of conditionals that have either standard curve or full curve, or drop curve rather. Now conditionals work by having targets assigned to them. So what I'm going to do is generate a couple polylines that represent where my drop curve will be. Now here's the first use of Corridor Mapper. Now I'm doing this one ped ramp at a time, keep in mind. You would be doing this for, however many you have, and you would do some of these steps all at once so that we're grading out and designing all these ped ramps at once. So I'm going to run setup targets. And if I jump into Corridor Mapper, here's that interface we saw in the introduction. I get a list of all my subassemblies over here, and on the right side I get a list of layers, styles, and if I choose, object names or descriptions that I can link to. These are dynamic links that we set up. For example, here's those boulevards. I'm targeting geometry out here to control the width of my boulevard. And I'm doing that by linking to a layer. That layer stays linked to these subassemblies so that as I draw additional objects on that layer, I simply refresh the corridor mapping and the targets come in automatically. Up here I've got baseline filters, I've got region filters, and I could even come down here right within my subassemblies and just start typing, and it'll trim the list of subassemblies. Here's all the ped ramp conditional subassemblies. Okay, I'm on the width and offset tab, but there's of course slope and elevation and surface targeting. I'm back on the width and offset tab. I've already got some of this corridor mapping done, right? So the thing about Corridor Mapper is you define some of these links in some cases before you even built out the targeting. And then you just drop things on a particular layer and the targets come in automatically. I show a lot of that in the intersection webinar, so be sure again to check that out. What I've got here though is all these ped ramp subassemblies linked to the ped ramp drop curve layer. That's the layer that I drew these magenta polylines on. That layer is already linked. So if I simply hit OK, it's going to pull those new target objects in. You'll see the yellow hatching show up. And if I look back at my cross section, there's my sample line right here running through my corridor. This side is the right side. That's what we're seeing right here. So I have yet to grade the ped ramp area, but now we can see that drop curve showing up right in the ped ramp. And of course, if I move this to right here, we see that full curve. Okay, so that's how we handle the drop curve in the corridor. All right, let's grade the ped ramp area. First thing I'm going to do is I'm going to take this polyline, I'm going to create a feature line out of it. And what we're going to do is we're going to put this in the same site as all these other feature lines will go in. And we're going to give it a style of ped ramp sidewalk. And the styles become real important in this, and I'll show you in a moment why. We're going to assign elevations, and we're going to extract elevations from the corridor FG surface. Now my approach to this is going to be, we have a corridor FG surface, and then we have an overall FG surface. What we're going to do is paste the corridor surface into the FG surface, and then we're going to add these feature lines as break lines to that FG surface. It's never a good practice to add feature lines directly to your corridor surface, and this way we'll do a secondary overall FG surface. But for pulling elevations for that feature line, that we want to have it pull right from the source, right at the edge of the corridor, so we'll extract from the corridor FG. We're going to insert intermediate grade breakpoints and make it relative so that it stays sticky to that corridor surface. If I pick on that, you'll see it inserted elevation points where necessary. And if I look at an elevation editor, everything is relative to the surface. So now as my corridor changes, this feature line will move up and down with it. Okay, now what about the back of curb side? We've mentioned this before. We're going to take this and we're going to extract the back of curb feature line from that corridor. I'm going to leverage some styling again. I'm going to set this to ped ramp back of curb for my style. And for the layering, we'll grab a similar layer again. Okay. If I look in the settings here, what I want to do is make sure I have dynamic link to corridor turned on, and then the other options we can simply turn off. Click extract, and we get that feature line. Looks like I didn't quite set the style right. Let's pick that again. Look at my properties. That should be ped ramp back of curb. Now, what is all this about all these different styles? Okay, I gave this one a back of curb. I gave this one a sidewalk. Okay, we're going to create feature lines from these as well. Let's go ahead and do that. But these are now going to get a ped ramp wings style. We're not going to assign elevations. We're going to use AutoGrader to grade all those feature lines. We're going to put it in the same site though. Okay, and then finally, this is going to be a feature line as well, but it's going to be the ped ramp landing. Don't need to assign any elevations again because we'll set that through AutoGrader. Now, none of this has been graded out. There's some default elevations that have shown up there, but let's make sure we understand what all this business about styles is. If you go into your site in Prospector and then you expand it and you right click on feature lines, you can go to the properties of feature lines. This is a feature that's been natively in Civil 3D for years, just often a missed feature. If you go to the options tab, you'll see a list of all the styles in your drawing, and if you check on this filter unused, it shows just the styles in use in the drawing. Notice the list here. What does this mean? I can change the order of it. This is something called split point resolution, or kind of another term for it is feature line style hierarchy. What this means is that when a back of curb and a sidewalk feature line cross or intersect one another, the one with the back of curb style always controls at the crossing. Okay, I've got back of curb right here. Then I've got intersecting at these sidewalk subassemblies. From there, I've got the blue feature lines, and these are assigned the style of ped ramp wings. And then finally, I've got ped ramp landing. That's the yellow feature line here. Okay, so I've built kind of a cascading set of controls here at all these different crossings, and I've intentionally crossed these feature lines and made them separate. In fact, we made this inside one a separate feature line so that it could basically be pushed up and down by all of these blue wing feature lines. Okay, so setting up those styles, you build them in your template, have a few of those layers ready. Yours might look a little bit different than mine. The point is to leverage that split point resolution in your feature line styles. Okay, one last thing before we go ahead and start grading these feature lines. You always want to take advantage of slope labels on your feature lines. I've got this style built to just label the slope, but you can have it so it labels the elevation as well. But in my case here, I'm not really concerned with exact elevations. I just want to make sure the slopes meet my requirements. And clearly right now they don't at 20% and 11.19%. We got to do better than that. But at this point, we're ready to use AutoGrader. All these feature lines are talking to one another, so to speak. For example, if I grab this feature line and I push this down to a -2, you're going to see that yellow feature line change and those slopes update with it. So even without AutoGrader, which I'm about to show you, the setup we have now even makes it really easy to work with. Let's take advantage of AutoGrader, though. This is in the CIM Project Suite. I'm going to go ahead and open this. And what we have in here are two grading families. Now there's different grading family types in AutoGrader. Let's click the Create New Grading Family. We can do 3 different types. We can create parallel grading families where if I generate, say, a back of curve feature line, it'll automatically generate 3 offset 3D feature lines for me. I can do perpendicular where if I draw a baseline like this, I can grade out, for example, residential lots. Or in this case, what I want to do is I want to have it assign slopes from the back of curve and then run them up these wing feature lines. Okay, so perpendicular means it grades feature lines that are perpendicular or near perpendicular. I shouldn't even say near perpendicular. They simply can just be intersecting the blue feature line or the parent feature line in this way. Okay, hit OK to that. We're not going to create that, but that perpendicular family is what these two are made from, and you can see that right here. So let's go ahead and open up this family. The way AutoGrader works, you can give it a name, and then you start by defining your parent feature lines. If I click into here, I've got a filter that's saying grab all feature lines that are on the layer PedRamp back of curve. That's this one right here. It found one feature line. Now as we grade out more PedRamps, it'll automatically pull those in, and this grading family will grade out multiple PedRamps at once for us. Now if I look over here, I've got this set to grade existing. That means we have existing feature lines that we want to apply slopes to, and it's pulling those in or finding those based on a simple layer filter. Again, PedRamp wings. These are the blue feature lines out here. Down here, I can specify any number of grade breaks. This is pretty simple. All I want to do is hold a single grade to the end of this feature line. That feature line ends right there. That's partly why I made all these blue feature lines separate feature lines. And then there's a lot of different methods of how we grade these out. Different projects you guys might have, you might be thinking of ideas for those already, but the one I'm using here is a slope to end method. And all it's doing is it's going to hold an 8% slope to the end of the feature line. So what it means is any feature lines that are on this layer that intersect feature lines on this layer will get an 8% grade assigned to them. I've got 4 feature lines in this way. Pretty simple scenario at this point. But it'll apply that 8% from that back of curve sloping upwards at an 8%. I've also got controls on my styles and layers in here. Now when you're doing something like grade existing, you've already created the feature lines, you'll very likely have assigned the styles and layers you want, and then you can just set that to keep source. Finally, if we go back to the main page, I can assign the surface that all these feature lines get assigned to as break lines, and I can even control the level of detail of the triangles in that surface. We're going to go ahead and run this grading family. Now watch what's going to happen here. It's going to apply that slope I have to these feature lines. Now 2 of these intersect right here, so the last one edited will control. But let's go ahead and click this. Click Run. It's going to assign those grades, and then it's going to put everything in the FG surface for us. Let's close out of this and take a look. There's that 8%. Now this one's 6.75 because this one was assigned after. Now it's very important that we have these feature lines intersecting where that corridor back of curve feature line is at a flat curve, not at the top high back of curve, but at the flat curve here. Now I also have another grading family in here that works the exact same way as the front ramps one, but this is for the back ramps. It's doing the same thing with this green feature line over here. The only thing that's different is it's assigning a negative 4.5% slope, so it comes downwards. And then we can see what kind of slopes we have from there. So I'm going to click Run. It's going to assign that 4.5. Click Save and Close. Sometimes, yeah, I noticed one little thing here. This feature line, when we inserted grade breakpoints, it didn't pick up one right here. So I'm going to make sure we insert one right there. And as a confirmation, we'll extract elevations from surface again, make sure everything's relative to the surface. Okay. Now if I go back to AutoGrader, if I run this again, we should be able to see some slope assigned there. Oh, I see why it's not doing it. Because these two feature lines are intersecting, right? So if I made this steeper, for example, we would then see some grades starting to show up right here. So this is the way, right, that PedRamp works. It's always kind of a little bit of a puzzle. But what we can do with AutoGrader is we can get really close, right? I ran this, and it gave me decent slopes back here. Everything's looking pretty good on the front ramps, but in the landing, our slopes are too steep here. So you can go back and forth. You can run the front ramps one again, and we can even make them steeper. So our max grade in our requirements was 8.5. So it's looking like we've got to gain quite a bit of elevation to match back here where our sidewalk is. So we'll apply 8.5%. Okay. And then what I like to do is for the landing area in here, we could be controlling this with another grading family. What I find it easiest to do is just to be controlling this manually, setting those slopes as necessary like this. I'm going to just make it a 1.5% cross slope. That should meet our requirements. And then you can see what kind of elevations we're getting. Now, if I take a look at this, we've got 8.5, and then we've got 1.5%, we've got 9.2. It looks like it's all just, it's too small of an area to kind of maintain that kind of grade. Now, there's a number of things we could do. We could set up some targets so that this sidewalk coming into the corridor starts to slope down. But really what we need to do is we just need to expand the PedRamp area. We need to expand the area that we're grading with feature lines. We need to be able to have these feature lines extend further back so it's a more gradual transition into the typical section. So how I set up my corridor allows for this in a very expandable, flexible way. For example, I've got a polyline right here that I use in a set of conditional subassemblies right here. Here I've got conditional subassemblies that either build some type of curb or just build nothing. The build nothing is this area of the intersection where I don't want anything built after, you can see that blue outline there, I don't want anything built in this region after that edge of travel lane. So this is all one region right through the entire intersection for the main road. Okay, and I'm just using a kind of an empty conditional to have it turn off the curbs through that intersection. Now I use a simple polyline for that conditional, so what we can do is we can take this and say, you know, we need to extend the curb ramp region further back. That means that this region right here is going to extend further back now. And it also means that it's going to not build any curb or sidewalks or anything further back. So keep in mind, those layers and things are mapped in corridor mapper. So all I need to do, or excuse me, the targets are already mapped. So all I need to do is rebuild my corridor. And it's going to do a few things for me. It's going to back up the typical section for my sidewalk. And it also ensured that my ped ramp, this quadrant here, is now built all the way out to there. Okay, now we have a larger area with which to work with. If you've set this up simple enough, you can just do some manual edits on your feature lines. So there's that sidewalk one. I'm going to verify through the elevation editor. Looks like some of those reverted to absolute elevation. We want to make sure they are pulling from corridor FG. Okay, so I'm going to run this again. Make sure we're matched into that. So that's stuck to the corridor FG surface. And all we got to do is grab these and connect them back here. Okay, and now we're getting much better slopes. If I look around, it looks like all my requirements are met. Okay, I could even go back in AutoGrader and run these again, but since we have enough space, right, these slope transitions are going to be within our requirements. Now at any point, you can move anything around, right? If the sidewalk needs to bump out further, you're just moving a few of these polylines and feature lines. At some point, it might be worth just kind of redrawing them if there's a drastic horizontal change. But this is the general approach we're after. Now, if your ped ramp design is different than this, there's tons of them, I know that. You're still after this approach of boxing and a ped ramp area. You've got a sidewalk area, a sidewalk feature line, and then you've got a dynamically linked back of curb feature line. Draw your polyline geometry in, and then use those two boundary feature lines along with AutoGrader to assign slopes to those feature lines. Or even if you don't use AutoGrader, set up your feature lines inside here so that they stay sticky to those boundary feature lines, right? That's that feature line style hierarchy or the split point resolution that we were talking about. Make sure the boundary feature line styles are the ones in the top of the list, and then the kind of dependent ones. In this case, I've got priority 1 is the boundary ones, then the wings are priority 2, and priority 3 are these. Basically, everything controls these where intersecting. In this case, it's the wings. Okay, so that's the approach to it. Let me run through it again, and you can see kind of how fast this would be. Now, this is one ped ramp in a corridor that has 4 different ped ramps. I'm not going to do all of these, but I'm going to do one more, and you're going to see how that same grading family can be applied across multiple ped ramps. So let's repeat it over here. First thing we did, we pulled polylines from the corridor. This was just a quick way to generate geometry that we can use. Okay. We ran an offset of our lip of curb alignment so that it's at back of curb. Now that was 2 feet for me. It might be different in your design. And we extended these polylines to generate our ped ramp geometry within our ped ramp area. Then we drew our backside boundary to our ped ramp area. Now I'm just crossing over right here. Okay. Now the assumption is that you've got a surface boundary of sorts to kind of trim these out. Some kind of existing feature line you might be matching into. Not going to get into surface boundary creation, but that's how you'd be handling some of that. I'm going to trim these polylines back. Okay. Now, this stuff is unique for every ped ramp, right? This might not be quite a 90-degree angle. Now, if it is, there's some nice tricks. You can generate some blocks of this geometry, throw it on your tool palettes and bring them in. You know, that works if things are fairly standardized. But if it's this kind of thing, sometimes it's easier just to draw them out each time. Okay, I'm going to delete that polyline along the back of curve. That was just a temporary thing. I'm going to trim these out. Okay, and then we drew a polyline right in here, a single closed polyline representing the landing. Now let's do some layer assignment here. This was on the ped ramp landing layer. These were on the wings layer. This is the ped ramp sidewalk layer. By the way, I like to do this as I've generated the polylines because when you turn them into feature lines, there's an option there to use current layer of the object. So it just uses the layer that's already assigned to the polyline. Okay, next thing we need to do is draw those polylines for the drop curve, right? These are targets in our conditional subassemblies right here. So it knows where to put those in. I simply run corridor automap targets, click on my corridor. Remember those layers that were all assigned and linked and everything? It's going to now pick up these additional polylines and assign those conditionals that drop curve. So there's that hatching giving us confirmation that we have drop curve in that area. Next, I'm going to generate my feature lines and extract a feature line from my back of curve. We'll just extract them first and then give them the appropriate layer and style. Sometimes it's easier in the properties window than in that extraction window. So back of curve for the style, then the layer will go ped ramp back of curve. Now you could let all these go to the same layer and just leverage styles for everything. You can't do the reverse. We need to use style differentiation for that split point resolution. I like to leverage layers in AutoGrader, right? We were using these layers to pull in different feature lines to control those grading families, but you can also use styles for that. Okay, we've got our back of curve feature line. We need our feature line right at the sidewalk area. This is to close in our ped ramp area. I'm going to assign elevations. This is going to be the ped ramp sidewalk. It's going to pull from corridor FG. Okay. There's that feature line, elevation points inserted. And finally, these we're going to select. They're going to get feature lines turned into feature lines as well. These are the wings style. We don't need to assign elevations, but make sure it goes into the same site. And finally, this is turned into a feature line, and this gets the ped ramp landing style. Finally, we can throw a few labels on here to help us out. And then from here, AutoGrader will do the rest. Let's open up AutoGrader. These same grading families. If I go ahead and open this up, check it out. Now it's two feature lines. It's now picked up this additional back of curve feature line. I simply run this. It's going to apply those grades to those front ramp feature lines. I can run the one in the back. And it's going to apply those grades from the sidewalk back down. And then I go check it out, see how my design turned out. Okay. I need to have it flatter in the back ramps. So I'm going to go back into AutoGrader. We're going to have the front ramps control. And I think that's what you'll find a lot of times. And then we'll come into our landing here. We'll assign a few slopes that make sure we're meeting minimum requirements. And then I'm getting 7% slopes here, pretty flat over here. Everything's looking good. Okay. And just like that, we can grade out ped ramps. So what I recommend is grade out, draw out the geometry for multiple ramps at once, and then go into AutoGrader and Quarter Mapper, generate this stuff for you, then do your tweaking after the fact. You might even leave your tweaking kind of towards the end, right? It only takes a few little feature line edits to make that happen. So that's what I had for you guys today. Thanks for watching. If you're wondering how do you get these tools, Quarter Mapper and AutoGrader, they are part of the CIM Project Suite. If you don't own the CIM Project Suite, you can download a trial and contact your reseller. That is ATG in the USA, SolidCAD in Canada, and outside of there, contact us directly, CTC Software. So the trials you can get from ctcsoftware.com. So with that, I thank you all for watching. Wish you a wonderful day.